Oh, hi. This is the Mathization channel. I'm going to derive a formula for the area of a circle using triangle segments of a circle. And the more you have, the more triangle segments, the more accurate the circumference will be and area. The B is, the height of the triangle is the radius of each one, and the base slightly curved, but the more you make them, the more that approaches a straight line. The higher you go. Okay, and you don't have to calculate the curve into it. So the area triangle is the base times the height, was the base times the radius divided by 2. So see if I can, let's see here. So the circumference is the sum of those base values from B1 to Bn, and I'll make as many as possible in as many terms as possible. And well, that, since B is the same, that could be represented as multiplication depending on the number of triangles. So C equals the number of triangles times B. Okay, for each triangle, the tangent of the angle is the opposite side divided by the adjacent side. And since the adjacent side is the radius, so we have B divided by 1, and B equals tangent of the angle. So if B is 1 degree, say, we have this value, 0.017, etc. How many B values can be along the circumference? Well, it depends on the angle you choose, so it's 360 degrees divided by the angle of each segment. So if you use 1 degree, well, it'll be 360 terms or triangles, and mathematically the angle equals 360 degrees divided by the number of terms. So, and mathematically then, C equals N times B, and then N equals mathematically C divided by B. And here we've calculated circumference as 6.28 something. So C divided by the radius is 6.28, and C divided by the diameter is 3.14 something. So mathematically, C equals, so that's like pi. This is a pi value here. The ratio of the circumference to the diameter. So we have circumference equals, bring that over here, pi times diameter. So, and that's equal to 2 pi r. Okay, and then the more terms you use, the closer it gets. I think this one was 1,000,000 terms, and I think it got 9 digits of precision, accurate, past the decimal point. So, okay, from that value, you can calculate the area of a circle. So the number of triangles times the area of each triangle. Okay, and so right here, so we have N times the area of each triangle, so the base times the height divided by 2. This is B times R divided by 2. And then N equals C divided by B. Put that here. And then circumference, we know that's 2 pi r. Bring that here. Then multiply everything together, and you get pi r squared for the area. Okay, thank you.